what's up, everybody? Welcome back. Today, we are trying to render some fonts with no dependencies, because I have a terminal case of not invented here syndrome, and we have to draw text on the screen sometimes, you know? So context is we're working on our like image editor, and it's getting pretty close to the point where it's like actually usable. Like I think that I could almost make any thumbnail that I've put on this channel, except for the fact that sometimes you want to put a red arrow on something and say doctors hate this one simple trick, and then if you want to write doctors in your thumbnail, you need to be able to render text. And of course, we cannot pull in a text rendering library. That's cheating. We don't want to cheat. We want to start from scratch. So today's goal is to try to figure out what the hell goes into a font renderer. So I've been I kind of skimmed the, where'd it go? One of these many windows is the TTF specification. Yeah, I've been kind of skimming this thing. I kind of understand to some extent what's going on here. If you just type in like TTF spec into DuckDuckGo, because why would you use Google? You get to this page, and so it looks kind of like at a high level. They kind of have a bunch of rules about how fonts are pretty complex. You can't just say give me this shape, because these shapes are going to be rendered on like pretty low resolution items, right? So they have a bunch of rules for like how are we going to snap stuff onto a pixel grid, and that is kind of built on top, I think, of this concept of like Bezier curves. So I think that they kind of have like these glyphs. These glyphs are made up of Bezier curves, and then they have like a program that runs in a virtual machine that basically like has a set of instructions on how to adjust this thing depending on your grid size. That's kind of like the extent of what I understand from what I've read from the spec. But we'll kind of see. We'll see where we get. So the plan of action is to try to like open a font, try to figure out what the fuck is in these like font tables. So each font starts as like a list of tables, and within these tables you have like character mapping data, glyph data, like how you like information about how you move from one character to the next, how wide these things are, stuff like that. I would like to find a glyph for a character that we're working with. So I would like to start by trying to like render out an A, maybe try to find the points that are associated with the character A, and then like draw those somehow, render an outline, fill her in. That's kind of like the plan of action. I don't know how far we'll get because I don't really know how hard any of this stuff is because I did very little research. So we'll see how it goes. Let's start by making a new project. So let's get out of this image editor workflow that I was working in happy hour, and let's start by copying our environment, and we'll be like font rendering, and we'll paste it over here. Okay, what do we have in this thing? We have Valgrind, GDB, Zig, Python, GLW. We probably don't need any of this stuff. Perf might be nice to have later. Coverage tools might be nice to have later, so we'll kind of leave it as is like that. Let's also get a font file to work with while we wait for that. So can we look for like my go-to monospace font hack? I actually don't know if this is what I happen to be using in my terminal right now. I just know that every time I've looked at it, I like it. So we'll download this. We're probably gonna find out that I've downloaded this before, but that's okay. And let's just kind of pull this guy. One. Tar. Okay. What's in here? We have some fonts. Okay, cool. Let's make a source directory and do source main zig, and we have to do our get up and running pub function. Main is gonna take in nothing and return void nothing as well, and we'll do a little maybe return error to say that we have a program. We zig run source main, and he goes, great for us. And then maybe in the future, we're going to want to set up a build script. But for now, we can get away with just typing zig run. Probably want to get init here so that I have my tools work, and also so we don't get lost. And in here, we probably want to set a get ignore that's going to ignore the zig cache, as well as the zig output directory if we end up using one later. Okay. Cool. So let's try to open a file. So, maybe we will pass in which file we want on the command line. So let's just kind of get some args and skip the first one because the first one is the process name. So, and we'll try to get the font file is args next. And if this fails, we'll be like, please provide, maybe we'll like log log error. Please provide an input font. All right, cool. And then we return error no font. And then we should be able to open this thing. So const f is std fs current working directory open file of font path with I don't give a fuck arguments. And we probably would maybe want a buffered reader, but instead we're just gonna type like read to end alloc probably. Just fuck it, we'll pull the whole thing in with some allocator we haven't figured out yet, and like a max of 1 megabyte. I guess we should set up an allocator. So general purpose allocator is the heap general purpose allocator from Zigland. I don't give a fuck arguments. At the end of this thing, we're like, could you please clean yourself up to check if we have any leakies? So we kind of like do this, and then we get the general runtime interface out of this thing. Boom. Okay, so theoretically now, we have the font data in here, and let's just do a little font data is this many bytes, you know? We gotta start somewhere. Font data len. What do we got? Fuck! This thing needs to be variable because the general purpose allocator will need to track some state, so you can't just use constants. And we do need to provide an input font. I forgot. So can we look at hack regular? Cool. So we do have font data is a size, and the memory allocator is complaining because we did not free font data. And we don't want to free it before we use it. We actually want to free it after we use it, which is crazy, I know. But boom. Okay. We have some font data. And now I guess we have to find out what the hell is in it. So somewhere I think it's here they talk about font tables. They talk about like the general file structure of this thing. True type font files, an overview. Here we go. Consists of a sequence of concatenated tables. A table is a sequence of words. Each table must be long aligned and padded with zeros if necessary. Okay. First of the tables is a font directory, a special table that facilitates access to the other tables in the font. Sure. The directory is followed by a sequence of tables containing the font data. These tables may appear in any order. Certain tables are required for all fonts. Others are optional. Cool. Okay. Tables have names known as tags, blah, blah, blah. Okay. So like what is the first table? Are you telling me that if I like just, hex dump -c ttf hack regular, it kind of sounds like there's no like magic or anything. It seems like they're just like fucking running it at tables immediately. Yeah, so dsig is, I assume, the special signature table that they call it. Was that font directory special table? So what is dsig in here? I don't see that anywhere, which is kind of interesting. gsub ttfa. So I do see like cmap. I recognize that word here, cmap. But I don't really know what's going on here. VOS2 ttfa. So how do we? Where's like the top level structure of this thing? The font directory. The first of the tables is a guide to the contents of the font file. It provides the information required to access the data in the other tables. Yes, the directory consists of two parts: the offset subtable and the table directory. The offset subtable records the number of tables in the font, blah, blah, blah. The table directory consists of a sequence of entries, sure. The offset subtable documented in such a... Dude, can just, like, give me the fucking... What's at the start? The table directory follows the offset subtable. Okay, so we start with the offset subtable. Begins with a scalar type of the font. The number is tagged tables in the SNFNT follows. The number of tagged tables in this thing follows. The table directory itself and any subtitles are not included in this count, blah, blah, blah. So is this what we're looking at? A tag to indicate the OFA scalar to be registered as the font, blah, blah, blah. Dude. This is a lot of words and not a lot of just like, give me some byte offsets. Please, dude. Okay, so we start with a bunch of tables. First of the tables is the font directory, a table that facilitates access to the other tables. So then they talk about the font directory as the first of the tables. It consists of two parts, the offset subtable and the table directory. The offset table is this thing, and this is the offset subtable. So theoretically, we should have 4, 5, 6, 7, 8, 9, 10, 11, 12 bytes, followed by the table directory, right? And then the table directory has a 4-byte identifier. So we do see our first 4-byte identifier, maybe, right? We could maybe like hope that this is the first 4-byte identifier. And so we could say that this is, each line here is 16 bytes. So this is 12 bytes offset, which lines up with this 4, 5, 6, 7, 8, 9, 10, 11, 12 thing of like the offset table. So I think that that's a pretty good clue. If dsig is something reasonable. So what is this like tag supposed to be? Entries in the table directory must be sorted in ascending order by tag. Each table in the font file must have its own table directory entry. Table 5 documents the structure of the table directory. So we have a 4-byte identifier, checksum for this table, offset from the beginning of the format, and a length. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 bytes. And so I assume that the offset table tells us how many elements are, number of tables. And so probably we should just have like num tables elements of 16 bytes, right? Which kind of lines up. We have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Like this, we see like if we just look down the right bar here, a bunch of 4-letter words. And not swears, just 4-letter words, right? And so we can kind of probably assume that we have, what, this is 16 elements, I think, is what we see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 16, I'm pretty sure. And so we should see that the offset, the number of elements specified here, should be 16. So this is after 4 bytes in, 1, 2, 3, 4. 1, 2, 3, 4. We have 2 bytes of num tables, which is 11 hex, which is 16. So I might have been off by one. It might be 17. Which I think all lines up. Fuck, what did I just do? Okay, so I think we have like a pretty good sign that we kind of get this a little bit. So let's start with the offset table. Offset table. And so that's just kind of like, whoop, this shit. Let's macro this to go forward, delete. Okay. And, oh, we probably wanted the first word in here, huh? So we probably want to go word delete. Nice. And then we can bring this over, and then we can kind of like delete all of these ints from here, and then do a little macro to go word delete back paste colon. Okay, there we go. Pretty chill. Pretty chill. And then we probably want to zig format source main. There we go. That fixes all of that. And then we want these to be you know, a little bit of, what is this called? Snake case instead of camel case. Nice. You've probably seen it, but Sebastian Larg has an awesome video on font rendering. Yeah, that's it is. I did watch it, and I felt like I cheated by doing so. But yeah, he has done this, and it is a good video. Okay. Let's see. So in here, we just want to look at the font data, and we're assuming. Does it say anywhere in here like endianness? Endian network. Byte order, little, okay, not in here. Let's just kind of quickly, byte order, network, little, nope, not here. Byte order, high byte, ooh, word, I think I saw in here. Byte, high byte repeating first. Hold on, yeah, okay, hold on. Font engine, this is kind of, doesn't really seem right. Introducing fonts. It really feels like it should be in the font table, but I guess we can always just figure it out. I mean, we have a guess here. We'll just figure it out based off of, here, we know that it should be 16, which means that this is in big endian, right? That's the assumption that we can make, is that everything is going to be network byte order. So what we want to do is if we were to just cast this thing from like 0 to we do like stood mem as bytes as value. So we like take the offset table and we go from like font data from 0 to bit size of offset table times 8, and then we need this thing to be like packed if we want to do it this way. We would, if we took this and we said like we have this many tables, and then we look at like offset table num tables, I think it's not gonna like us. We have way too many. 4, 3, 5, 2. Way too many tables, right? But if we do like a little bit of a little stood mem big to native on this thing. Fuck. We need to tell it what type. U16. He's like, we have 17 tables, which is what we guessed looking at this thing, right? So we can do a little bit of trickery where I think that we've done this before, where we can do like function, like endian, fix struct endianness, which will take in some sort of like value, right? I guess we can call it just fix endianness, to be honest. It's not really gonna, if it's gonna take in any type, it's gonna take in any type. And this is gonna return the type of val. And what we can do is we can go like, give me some type info about the type of the thing you passed in, right? And we can be like, okay, let's take a look at this thing. So if we are a struct, then we are going to basically try to iterate over the fields of that struct. Right, so we're gonna be like, oh, we already have this thing. Is already like this, fields. So the fields here, oh no, wait, I'm stupid, hold on. So we take the fields of the type, so it's s dot. What does this thing give us? This thing gives us a struct with fields. Ah, there it is. Okay. Fields. And we can go like inline for each field in s fields. We're gonna be like fix endianness of val at that index. So I think it's like field of val with f name. I think that's how we do this. And then we can do like ret is going to be a thing that is the same type of the thing we taught in. And we're going to say that the field of ret at f name is equal to the fixed endianness of that thing, right? Then we just have to like recurse and say if we get like an int, we just say like stood mem big to native of that thing. So we're going to look at the, presumably this is going to tell us what the actual type is. It's just bits. So I guess we just say type of field ret. Oh, I guess it's just type of val here. Yeah, and then we just slap the value in. And then else we just say compiler unknown type how do we do this? Info dot name or something? I don't know, something like that. He doesn't like that, but I'm sure that there's something in here. Type info. Tag name, I guess. Tag name info. Might also use byte swap all fields. Fuck! I didn't know it exactly. We looked for it last time and we couldn't find it. God damn it, dude. Well, um, unknown type pointer. That's weird. There are no pointers in here. Well, now that you've told me that exists, I guess fuck this shit. Byte swap all fields. Oh. So I guess here we could just do like our fix endianness function just goes like if const built-in we say if built-in dot CPU arch endianness. If this is big, we just return val. Otherwise, we return std mem byte swap all fields val. That's much better. Let's just do that. Let's just do that. Expected 2 arguments, found 1. Fine. Type of val. That's way nicer than whatever the fuck I was gonna do. He's mad because... Oh, we need to take in an ampersand val, I guess. Oh, and I guess we need to be like var ret is equal val, and then byte swap all fields of ret, and then this doesn't return anything. Yeah, that's what we want to do. All right. We're close. Expect a struct or array as the first argument. Am I stupid here? What does bytes' value return? Oh, bytes 2 value maybe? I want to copy it out, not get a reference to it. Much better. Here we go. We have 43,000 table though because I accidentally swapped it again. So now we should be able to be like offset table nom tables. Please? There we go. We have 17 tables. Let's go. We got there. Okay, so let's look at the tables again. Font tables here, and somewhere they talk about like what the table directory has. So const table directory entry. We give it the same treatment. So we just kind of like slap this shit in here. We delete these like ints. We say macro, I don't know, delete word, end of word, colon, paste, delete. Sure. That kind of worked. We need to do a insert this and case swap, and I guess that's kind of like the only time that's gonna show up. And I think we're chilling here on end of lines. Okay, cool. So what we're gonna do is, I guess, we're gonna say for 0 offset table nom tables, I guess. We're gonna do something. I don't know what yet. I guess we're going to look. We're gonna say that the table directory start is gonna be the bit size of offset table times 8. And then we're gonna be like, wait, times 8 over 8. Oopsies. You might have to be careful about package struct sizes that are sizes lined up with just like integer sizes. Yeah, we've hit that before, which is why I'm using bit size of instead. So here, I guess we're gonna be like, tables is going to be like the font data from table entry directory start to I guess like table directory end is going to be, I guess, like the font, the start plus size of the table directory entry This is going to be multiplied by the number of elements. That sounds right. Right? That sounds right. I guess we don't really need brackets here. And then here, we should be like, bytes as slice of these things. And I don't know if this is going to be like, I don't know if this is going to be a problem. So can we just be like, let's just make sure these things match up. Yeah, so we got the word number 17 twice, which means we probably parsed this thing correctly. And we can just go like for tables, we have some table. I guess we need to fix the endingness of this table. Table big, we'll call this. And then we can just start looking at stuff, right? So it can be like, can we just look at the table tag? I don't know why the he doesn't really seem happy to type tag here, but maybe we'll try to do it. And these tags are, I guess the tag, instead of writing U32 here, I'm going to write 4U8. I think that will let us print this a little bit better. Table D has name S. That seems reasonable. So tag here. And the index is going to be somewhere. Okay. That should be reasonable. Let's see what happens when we do that. Fuck. Packed structs cannot contain fields like this? Oh, it sucks. Extra instruct? Maybe? Let's go, baby! Let's go! Okay. So that's pretty chill, right? We have our table list now, which is pretty sick. Pretty sick, if I do say so myself. So this is sometime before now. And now, let's try to find the letter A. So, I think here, somewhere, they tell us what, like, the top level important things are. Yeah, here. They say these are our required tables. CMap is a character to glyph mapping, glyph is glyph data, and then everything else I probably just don't give a fuck about. Probably. Right? So let's look at the CMap section and see if we can figure out how to like extract which glyph is the letter A. So this table maps character codes of glyph. Dude, this spec is so many words. I want just give me like format. I don't want to read. I can't read. I'm incompetent. I just want to see these, but like in like, you know, with a little bit of fluff, but not a lot of fluff. Okay, the choice encoding for a particular font is dependent upon the conventions used by the intended platform. A font intended to run on multiple platforms with different encoding conventions will require multiple encoding tables. Sure. So there's like, you know, Windows is going to do one thing, Linux is going to do another thing. Your font file, if it wants to support Linux and Windows, has to have like multiple character map tables. Because like Windows might be UTF-16, Linux might be UTF-8, whatever. Character codes that do not correspond to any glyph in the font should be mapped to the glyph index 0. Okay. At this location in the font, there's a special glyph representing the missing character. Cool, duplicate box. No character code should map to glyph index XFFFFF, which is reserved to indicate the position of a glyph deleted from the glyph stream. I don't know what that means, but we'll kind of just ignore it. CMap table begins with the table version header, followed by the number of encoding tables. Okay, cool. CMap. So first we're going to have table version number followed by the number of tables. So here. And then each of these we're going to have 3 fields. Offset of the mapping table. Okay. So here we're like, The original definition of the CMAP used either 8 or 16 bits for character codes, and support for versions of Unicode 2.0 onwards. It is possible that fonts may require references to data that uses a mixture of 16 and 32 bits per character. Or simply 32. Okay. So this tells us the number of encoding subtitles. Then we have these. Then the offset will tell us, this will tell us like what the format of the thing that we're looking at is supposed to be. And then here is like where it is, presumably either from where we are or from the start of the table. So maybe we'll do this. CMap parser. Is gonna start with like the CMap bytes, is probably the easiest way to do this. And then we're gonna be like read, what was the first thing called? Offset table? Read index. Okay. And so he's gonna give me back like index. Packed struct probably is the reasonable way to go here. And in here, we're just gonna have like version and number of subtitles. Subtables. Num subtables is also a U16. Okay, let's start here. So we're gonna be like self bytes from 0 to bit size of index over 8. And we're gonna like try to like extract that thing. So we're gonna be like std mem bytes to value of index. Okay. And then we're gonna have to byte swap all fields. So fix endiness. Boom. Okay. So we are actually gonna have to figure out which of these tables is the CMAP table. So I guess we'll say like var CMAP index is a nullable U size equals 0. Okay. And then what? I guess we could like kind of just do this as we go. So we'll say like if I guess we'll say if table tag is equal to CMAP, we're gonna do something. Hello, I would like to put a bracket, not a star. Thank you. And in this case, I guess we will feed him the table directory entry. So here, the offset is the offset from the beginning of the file. Are you trying to do bitmap font rendering here or something more sophisticated? I don't know. I haven't got that far, man. I just want to put some characters on the screen. Okay, so where is this like offset field? From the beginning of SFNT. What is SFNT again? The number of tag fails. Okay. What the fuck is SFNT? That's not like a thing that we have in here, right? No. So the number of tag tables in the SFNT follows. Oh, so the SFNT must be the directory, the table directory entry. So the offset must be relative to this table directory start. We'll make that assumption for now. C's fonts. With like Z's and stuff, so you're trying to sound like D's nuts, I guess. It's pretty stupid. Okay. So we have offset here. And I guess we say that like the CMAP thing is going to be from like table directory start plus this. And we'll say like CMAP start is here and CMAP end must be from length. So CMap start plus table length, I guess, seems reasonable. And so then we can make a CMap parser with CMap bytes equals to our font data from the CMap start to CMap end. Let's start there, and then we can kind of see if what we have is reasonable in any way, shape, or form. So if what we have is reasonable, we're kind of hoping that when we read the index, we can see something of value here. Fingers crossed. Very stupid, but it got a laugh. That's true. You did get me. When we do this like comparison here, we need to put a little ampersand. That's true. And okay, we have version 3, number of subtables 1. That's not insane. That's like a maybe. What are like valid version fields here? He does kind of claim that it should be 0 here. So maybe we got unlucky. Maybe we did something wrong here. It kind of does seem like it should be unconditional here. But we could just try to read the subtitle tables anyways. And we could see if it's reasonable or not. So read subtable. And this is going to return us one of these, I guess, right? Open the file in hex editor to verify. My problem here is that we don't know. We're trying to guess where the offsets are here, right? So we have these like table offset and table length. We just don't really know what they mean. I thought they were supposed to be from the table directory start, but we could have made a mistake here. For sure. But we'll see. We'll see. So we have some 16s and U32s, and this is going to be platform ID, platform specific ID, and offset. Okay, we'll see if these look reasonable, and if they don't, then we will kind of loop back. Boom, boom, boom. Okay, subtable. And if we're expecting to read one of these from somewhere, I guess it's gonna be like CMap bytes plus the offset of the index. Right, and I guess that's it. That's like immediately where we start. And then we're gonna increment by IDX times the size of the subtable. Right? That seems reasonable to me. That seems reasonable. And then const end is going to be subtable size plus start. So we might as well do this. Right? Boom. Boom. And then put IDX times subtable size here. And then do start plus subtable size, and then return fix endianness stood mem bytes to value of subtable from self cmap bytes from the start to the end. All right, let's see what that does for us. So here we're like subtable parser read subtable at 0. Zig run. Fuck. Yeah, this should just be like this. That's true. This is a line, this guy. Platform ID 0, platform specific ID 20. Yeah, that doesn't really seem likely, huh? know, maybe. Indicode's Unicode version 20? That's not crazy. How many Unicode versions are there? I'm pretty sure that we're past 20, right? No, 17? Okay. Feels wrong then, huh? Feels wrong. And this feels wrong as well. So we're likely just doing something wrong. So can we try doing offset from 0? This gives us version 3 offset 20. Maybe this is more reasonable. We have 2 subtotals now, so can we say, let's go over each subtotal. For 0 to index num subtables, can we just print out what we get? So we get platform 0, platform 3. These have the same offset though, which might be okay if the parsers for those subtables are the same. Might be. I'm not like 100% off that yet. So 0, okay, platform ID 0 is Unicode, 3 is Microsoft. And then platform specific be Unicode version, and then Microsoft encoding. 3 is PRC. Oh no, it's 1. Unicode, BMP only, UCS2. Maybe. That's not impossible. The Unicode encoding has platform specific ID 3. Oh, yeah, wait, those match up. Those match up, right? Unicode 03 is Unicode 2 BMP only, and Windows 1 is Unicode BMP only. So maybe I'm not crazy against that. A Unicode subtable is one supporting the Unicode text encoding standard. Such subtitles have a Unicode platform ID and platform specific ID other than 14, or a Microsoft platform ID and a platform specific ID of 1 or 10. Yeah, all right. Most fonts should have a Unicode encoding subtable. Fonts with a Windows symbol encoding table 30 should have no Unicode CMAPs. Okay, weird. It's weird that they're exclusive, but whatever, I'll shut the fuck up. If a font has multiple Unicode encoding subtitles, each character should be mapped to the same glyph by every Unicode subtitle in which it appears. Fonts should not have more than one Unicode variation sequence subtitle. Font is blah, 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 blah. Subtitle search order. I really don't care. Just like, what the fuck is in this thing? So where is the like CMAP format? We just have offsets. So where does like the fucking start of this thing come from? Subtable search order, blah, blah, blah. The CMAP table and language codes. Here we go. Each CMAP subtitle has 2-byte language code associated with it. The language code is only used for subtitles with a Macintosh platform ID. For such subtitles, it is interpreted as one or more than a quick draw language code, or 0 if the sub blah, blah, blah. Each CMAP subtitle is where's like your table? Here we go. Oh, we have to determine which format we're in. How do we know what format we're in? Oh, the format is literally the first field. Nice. Okay. So let's say here is Unicode. Right? We'll start here. Function is Unicode. And here we'll just say like return platform ID is equal 0. I guess we probably want something a little bit more specific. We'll say is Unicode BMP. We'll say platform ID 0. And then, and platform ID is 4. Sorry. 3. And then this is like one option. Or platform ID is 3, I think it was, for Microsoft. And Unicode encoding is 1. So we'll call this is Unicode plus BMP, and then we'll say Windows plus Unicode UCS2. For now. For now. How can platform ID both be both? Yeah, they can't be. I'm just an idiot. And you don't have to call me out like that. Okay? Like, I know that I'm fucking stupid, but you don't have to say it out loud. God. Okay, so we'll just say here. I'm assuming that this is important to us. So I guess we'll say, like, if. We'll say count subtable is equal to this. And if subtable is Unicode, BMP, I guess, we will break out of this block or something. We could use functions like real programmers, but shut the fuck up. We'll call this like Unicode table offs. And if this is true, then we break block with subtable offset. Boom. Boom. So now we should be able to try to read this thing. So here we're going to ask for, I guess, the read table at offset. Shut up. Read table at offset. And here we're going to have an offset of usize, I guess. And we are going to return. Read, is this format? Each CMAP subtile is a 2-byte language code. So I guess this is the subtable header. We should be careful here. This is a subtable header. And this is going to be a subtable. Oh, this is going to be like a subtable index, subtable lookup, maybe is the word for this. I think is a better word for it. And then that means that we can read subtable at this offset. That feels a little more reasonable. And then can we just be like, hit me with the subtable, please? I guess I shouldn't have copy pasted because like nothing in here is gonna be the same. I don't know why the fuck I did that. And then this is going to be the start of subtable. So it looks like this thing has like multiple options here. So it's almost like we want to do like, we start here with a subtable format. And this thing is probably backed by a U16. Format U16, 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 U16. Yeah, okay. And what are our options here? 0 to... Dude, these are just numbers? They don't have names? Okay. So I guess we won't have a thing. Let's just read subtable format. So we're going to be like CMAP bytes at offset to offset plus 2. Stud mem. I guess we fix endiness of this thing. Stud mem bytes to value U16, and we return fix endiness here. Seems reasonable to me. Then we can be like stud debug print. We get the CMAP format is this. Parser dot read subtable format at offset. Unicode table offset. All right, let's see if this seems like something reasonable at all to us. Incompatible type C32 and void. Fine. How do we get out of this? I guess it's like this block has to come kind of here. And then if we make it through the for loop, break block. I guess we like just panic. Return error, no Unicode, bump tables. Okay. Fuck! So that's probably in here somewhere. Bytes to value, and then this we just need to be like in here, we can only byte swap all fields if it's a struct. So if it's not a struct, type info type of val. So this is the case where we're a struct. But if we are an int, we just call big to native of val. And he needs a type of val here. Fuck! Else compile error. Cannot fix endianness for type name. Type of val. Okay. Should be good. Fuck. What's he complaining about? Expected tuple or struct argument found U16. What? Cannot fix Indian. Like, can we just do this for a second? Oh, this is just somewhere else. Oh my god, I'm just a dumbass. Hold on, hold on, hold on. This can stay the way it was. And then this, I forgot to put this in a little curly braces. Alright, let's try that. Alright, CMAP format 4. Let's go, baby. Format 4 is a 2-byte encoding format. It should be used when the character codes for all font fall into several contiguous ranges, possibly with holes in some or all of the ranges. That is, the same codes in a range may not be associated with the glyphs of the font. 2-byte fonts are densely mapped and should use format 6. The table begins with the format number, the length of and language. The format dependent data follows. It is divided into 3 parts. Okay, can we just kind of... What? So this is format 4. So if the format is not equal to 4, return error unimplemented, and we'll say std log error do not can only handle Unicode format 4. And then here we can be like const subtable format 4 header. Okay. And I guess we're just like, these are all U16s, surprisingly. Okay, and then we do a little Vim macro magic. So we say go forward word, delete to the end of the word, go back, paste it, colon, end of word, comma, delete all line. Oh, tell me that's not cool. Tell me that ain't sick. And then here, I wonder if there's a way to like auto snake case stuff. I don't know what it is, so I'm just gonna put an underscore and a case swap, and then just find A to Z uppercase. All right, good enough for me. Okay, so can we be like read subtable format for header. New ball machine module. Yeah, somebody submitted it. I need to fix the clear code in the simulator. It doesn't, it like just is like a cool breakout module, and in here it doesn't work. So I just need to fix that, and I feel bad for not doing it, but it's just not at the top of my to-do list. What is the thing? This is like subtable format for header. Subtable format for header and subtable format for header. All right. So now we should be able to be like, parser read subtable format for header at Unicode table offset. Subtable header, I guess. And then can we like get some info about this thing? What is the thing? Subtable header. What's he saying? So we have format 4, length 3256, language code is 0, whereas language code 0 if the subtitle is language independent. Okay, so that's like a reasonable value. Seg count x2 is 2 times the segment count. Okay, search range is something like this. Entry selector, range shift 7, range shift 58 feels big for 2 times seg count minus search range. Oh wait, so we should be able to say this value of range shift should be 314 minus 256. 58, which it is, which means that we've probably parsed the right thing. That's good. That's a good little trick for us. End code, ending character code for each segment. This value should be 0. Reserve pad. It's not. That's not good. A little concerning. It's weird to me that like this stuff was right, but this stuff is wrong. But maybe it's okay. Maybe it's just kind of like, maybe it's not 0. That's okay. Start code 47, ID delta, delta for all character codes in the segment, offset bytes to glyph index array or 0. And glyph index array. Okay, I don't really know what this means. Brave search LLM says there are Vim plugins abolish and Vim case convert. Oh, cool, cool. The number of segments is specified by the variable seg count, blah, blah, blah. To use these arrays, it's necessary to search for the first end code that is greater than or equal to the character code to be mapped. The corresponding start code. Wait, so what is this? I thought that this is going to be like the header. Oh! Oh, some of these are arrays. Fuck. Okay, so we can't just map the structure then. Ah, this is where I went wrong. Okay. I see. I see. Okay, so we need to fix this. Okay, so this thing, we don't want to read it like this. We kind of want to parse it manually. End code is going to be some slice of these things. And start code is also going to be some slice. ID delta is a slice, and ID range offset. Dude, what kind of crazy asshole picked like the brightest fucking font of all time? It's so hard to read this shit. Glyph index array, also array. Okay. So in order to read these things, I guess we are going to, it might be nice to have some sort of like generic parser iterator that lets us like say like, here I am in some byte buffer, read me a U16, read me something else, like read me individual data types. So can we just be like data iterator, parser iterator? I don't know, man. Generic parser, sure. Over some data. And we'll store our index in here as well. and then can we just be like pub function read val, and he's going to take in like a comp time t as a type, and and self as a generic parser, and return t. Okay, and then he's just going to do something that's like self data at self index. Const size is going to be like bit size of t over 8, and then we're going to be like defer self index plus equals size, and we're going to be like, this is going to be self dot idx plus size, and then we're going to like return a stud mem bytes to value of this thing, and we're probably also going to fix the Indianness of it. Boom. All of these things combined, which means that now down here we can be like, all of these guys boom are going to be like parser, generic parser is a generic parser with kind of, I guess, the CMAP bytes from the offset to like literally the end of the world, I guess, seems kind of reasonable to me. And then we can just go like, for each of these, const this, I guess we'll do a macro, const this is equal to generic parser dot read val. Okay. Okay. And then we need to read an array, right? So that's the next thing we have to do here. Read array of this type. And he's gonna return a slice of this thing, right? And I guess here we're gonna have like a line 1 or something. Like the alignment of this thing's gonna be fucked up. But that's okay. Size here is just going to be this thing times the len. And then everything else kind of is the same. Fix endianness is probably going to have to figure out how to handle slices. But that's okay. And then we're going to be like, what was the next thing in here? It was the end code is ending character code for each segment. And this should have seg count elements. So here we should be able to be like end codes should be generic parser read array of U16s, and we want seg count x2 over 2 of them. Right? Seems reasonable to me. Then we should be like reserved pad is generic parser read val of U16. Right? Then we have start code, ID delta, and ID range offset. Start code, ID delta, and ID range offset. Okay. And then glyph index array, which we don't know yet. So we'll kind of like skip this stuff. And maybe this isn't a header anymore. This is just subtail format 4, to be honest. Maybe we'll say glyph. We could keep the glyph index right here as just kind of like unparsed. Or we could parse it later. Yeah, we'll just parse it later. Okay. So we should be able to be like return our shit, which is literally just going to be like for each of these things. We're going to be like yank till the semicolon, jump to the semicolon, put an equals, paste it, and then delete everything at the end of the line. Right? And then here we're going to be like put some dots in front of all this shit. Nice. And end code is mad. kind of go like this, and then whoever was calling this thing is no longer looking at the header. It's like literally just the whole thing. Whole shebang. Okay. IDX starts at 0 here, unconditionally. And here he's mad about like alignment here. So can we just say like align 1, just like fuck it, fuck my shit up. I guess actually we know we can probably align cast this, to be honest. Because I think we saw at the beginning that there was alignment constraints at the beginning. Wait, what's he pissed about? Expected type U16, found align 1 U16, but I align cast. Do I align cast here instead? Fine. Sure. And then here, can we just put some consts in here as well? Fine. Fine. We'll do it on all of them. Bum, 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 bum. Was he happy with that shit? 32? Yeah, I don't understand. Align cast here. Like, why doesn't this fix anything? Align cast discards const qualifier? What const qualifier? Const qualifier. Oh, because the data's const, sure. Cannot fix endianness for this shit? Sure. So fix endianness now has to handle slices. And does this thing handle? He handles arrays, but not slices. What about big to native? Does this handle it? No. Dun, 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 dun. Byte swap. I guess we can just go like. Oh, because I guess if we're byte swapping something and we're trying to return it, we kind of have to do it like in place, which is kind of weird. How do I want to do this? How do I want to do this? I guess I just won't think about it right now. That's the easy fix. Fix me byte swap. And then on read array, I guess we can like fix me byte swap smile. Okay. So that gives us something. Now, can we check now if this like reserved pad value should be 0? We just don't see it there? Why the fuck not? Is it like just giving up on printing stuff after it hits the range shift or the encode segment? Could be, could be. Could be, okay. We do need to fix these things, huh? So can we do something that's like, I guess we'll say fix endianness. We'll handle slices separately because we want to like do it in place. And we'll be like, we have some type, and the slice, right, is going to be this, and we'll return a new slice of t that was allocated with some allocator. I think that's pretty reasonable. Maybe it's not rather reasonable, but whatever. So can we do like alloc dupe the slice? Okay. Which means that this can fail. And then we just go for duped elem. I guess we don't really want to dupe. We kind of want to alloc this thing of slice len. And then for each elem in slice, we want like duped. We probably want to go by like index. We want duped I to equal fix endianness of slice I. And then we return duped. There's no way that this can fail after this, so we're chilling. And then now we can go like over here. We can look like end code. And I guess here, maybe we do it in read array. Read array takes in an allocator. And then here we can go like fix slice endianness of t with this. And then we return this. Probably with alloc as well. Sure. Which means that this can fail. All right, try here. Or the error will automatically propagate. Okay, and then here we need to pass in some sort of allocator. And use it all over the place here. Probably a line cast might go away here, I'm not sure. Let's just write some undefines to find out. And here we're gonna pass in the allocator here, and then this guy needs the allocator here. Expected this, found that 107, probably because we need to write try here, and then this thing can fail, which means that we need an error defer. Okay, we're getting close. At 33. He is mad because we need to line cast this, I guess, for it to work out. Chillin'. Now he's mad because what? Because the start codes are undefined, which are causing problems. So now we just have to do the same thing for these guys. So these align casts go away. These go away. Boom, boom, boom. Boom. Then we need to try here with the alloc. Boom, boom, boom. All right. Boom, 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 boom. Start code. ID delta. And ID range offset. Okay. And let's just slap some fix me error defers on all of those. Boom. Okay. So we have some leakies, which we will just ignore for a little bit, because I don't want to deal with them. And then we can look and see if these end codes are reasonable. These do seem to be some form of like incrementing thing with the final value of max int, which is I think that we saw somewhere. That's pretty cool. ID delta range offset. Where was like the reserve pad is 0. Okay, so everything seems like we're kind of getting some reasonable values out of this thing. Kind of just generally, it doesn't seem crazy to me. Now, what are we supposed to do with this shit? We are supposed to look at the glyph index address is the ID range offset of I plus 2 times C minus the start code of I plus pointer plus... What are we talking about? I want... Okay, what are like ID range offsets? Offset in bytes to glyph index array. What are like segments here? Each segment is defined by a start code and an end code. Okay, I see. So we have start codes and end codes here. And so if we're looking for a character code like A, we should be able to find that in the start code, like in the ranges. So we need the Unicode value for A, which I believe is just the same as the ASCII value for A. Unicode value A. Yeah. So this is 41. Okay. Which I think is the same as the ASCII value. Where the fuck is letters on this thing? Letters down here. Okay. So this is in 41. 41. This is hex. This is hex. Because here we have 41A. Okay, cool. So if we want to find the letter A, we have to walk each of these things for 0 to subtable header seg count x2 over 2. We're going to look at the subtable header. This is actually just the subtable, not the header. We need to look at this thing. We need to look at the end code and the start code. End code, I, and start code. And we need to look for the range of here that has our letter in it. So if this is greater than A, probably equal to, and this is going to be like less than or this is greater than or equal to, and this is less than or equal to on the start. I don't know if this should be equal to on the encode. End code. Where was encode in here? Format 4. Encode is the ending character for each segment. Ending. So this is inclusive, it sounds like. Sounds like inclusive. We will say std debug print A is in segment D. Okay, where this is gonna say I guess. Like this. All right. Fuck. This needs to be tried. That makes sense. A is in segment 4. Okay, so then once we find segment 4, we find the offset in bytes to glyph index array. So we go like glyph offset is equal to subtable ID range offset at I. Okay. Plus, right, this is the first index, I think. Offset bytes to glyph index array 0. And then to glyph index array. Okay. Then presumably we need to like add however many things there are to get to the letter A from the start code. Right? That's pretty reasonable. That's pretty reasonable. So we can say like glyph start bytes is gonna be, or we'll say like seg offset is gonna be A minus the start code, I guess. Then the glyph start bytes is gonna be from subtable ID range offset at I. Then we're gonna be like, I guess our glyph index array is like, what the fuck? Oh. ID range offset I plus 2 times this, so we kind of got this, plus a pointer cast from the ID range offset at I. Oh, so the byte offset is like from where in the table we are. Oh, that's fucked up. So the offset is literally from the value itself. The multiplication by 2 in this equation is required to convert the value into bytes? Sure, because each index is a U16. Okay. Then glyph index here is a number. If the ID range offset is 0, the ID delta value is added directly to the character code. So can we just say like glyph offset for table is this. Glyph start bytes. Let's start here. If it's 0, we can kind of just cheat. It's not. Okay. So the problem here is that like our ID range offset now is not like the pointer here is not like the same as where it is in the like the initial table. Right, so we need to be like we need to get crazy. We gotta get crazy. This is a fucked format. So we need to find the original pointer to the ID range offset, right? That's what we need to do. So here we need to keep like ID range offset base is going to be like ID range offset base. He's got to be like a pointer of some form. Right? Like something like this. This is fucked up. I'm just going to say it. Generic parser data at this index is where this thing lives. I guess we can do it like this. ID range offset base is equal to this. Now, what would be nice is if we could work as a slice, but we're not going to be able to do that. So I think what we want is we want like this thing to have like a function to find glyph index. Like get glyph index. Okay. And how are we going to do that? The glyph index we're going to assume is like a U16 probably. And this is going to come from like essentially this. Okay. So we need the start code, the index, I guess, right? As well as the character. Okay. That seems reasonable here. And then the rest of this might just kind of come for free. So we have the ID range offset base is this. Plus 2 times something. I think. I think that's this. base as star U8 might be easier. We could even maybe do it as a U16, huh? Because then we can do ID range self ID range offset base I. Kind of gets us this, right? Then this is just self ID range offset I like this, and self start code I. I mean, that's like a maybe, right? That doesn't seem crazy. Does not seem crazy, so now it's just that this guy needs to be like a line cast probably. Okay, and then we should be able to be like, get me the glyph index. Let's just see. Print the glyph index for A is this, which is subtable. What was it? It was like get glyph index using I and the character code of A. That's like a maybe. What's he pissed about here? Oh, I forgot bracket here. Fuck. Pointer cast the stars console fire 120. Fine. Yeah, this doesn't need. We don't need to like actually modify this shit. Do you finish the GIMP thingy or are you taking a break? Neither. This is part of the GIMP thingy. This is part of the GIMP thingy. We need to do this because we need to render some text in the GIMP thing, you know? Incompatible types, const U16 and U16. That's true. So how do I pointer add in this language? Pointers. Okay, let's think about this again. I actually don't know. I don't think that this expression is fair. Let's think about this a little bit more. So we have like the base address. Const reference address is going to be this. And this is going to be in bytes. So that's ref here. And then it's going to be ref at whatever the fuck we put into this thing, right? I think. Right? Because this is the ID range offset at I over 2. Glyph index address. ID range offset plus 2 times this. So C minus start code I is the offset of this in bytes. Plus 2 times. Yeah, okay. So ID range offset. Yep. So this is at this plus 2. I'm confused. The offset is this plus 2 times the distance between C and self start code I. That makes sense to me. And then do we really just do like ref offs? But then this thing has to be a U16, so ref offs over 2. That seems reasonable to me. I'm not sure it's right, but it seems reasonable. Expect to type this, found this. So we can like just like pointer cast this shit. All right, that's like a maybe. Glyph index for A is 37,000. Oh, and then we need to fucking fix the Fix endianness. Glyph index for A is 1425. That's a maybe. Okay, let's see what happens now if we just kind of throw a couple more letters at it, right? Let's assume that these are going to be in the same section, and let's just see if they're contiguous. No. Right, so that's a little concerning. I would hope that these glyphs are contiguous, but maybe they're not supposed to be. It would be interesting to look at the glyph table. And in the glyph table, we might be able to extract a length here, and then we can kind of check if our guess is like correct. So can we see like how many? Can we just like look at the top level thing? The glyph table. Glyph table contains data that defines the appearance of glyphs in the font. This includes a specification of points that describe the contours that make up the glyph, and instructions that grid fit that glyph. The glyph table supports the definition of simple glyphs and compound glyphs, blah, blah, blah. Number of glyphs in the font is restricted only by the value stated in the head table. The order in which glyphs are placed in a font is arbitrary. General table information. Okay. So table 14 documents the format for glyph definitions, a zero positive number of contours, single thing, blah, blah, blah. So how do I know? It must have something to do with the head thing. Head is going to say, contains global information about the font. It seems like we shouldn't have all these constants issues. Isn't the original data mutable? If we fix that, we might be able to avoid the dupe calls too. I think that I intentionally duped because I don't want to like modify the input data. I think that that's kind of like wrong, you know? I think that it makes more sense to copy stuff out that we're changing. So I like the const stuff is kind of intentional. Because if I like parse it twice, it would like, I don't want it to like invert, right? I think that you should be able to parse twice without causing problems. Okay. Flags give global information about the font, blah, blah, blah. Okay, how do I just like read this shit? This is the head table. And are any of these things variable? No, it seems like we can literally just like rip this shit as is. What is F word? Floating point 32 probably would be my guess. TTF F word. What the fuck is this thing? F word is a 16-bit signed integer that describes a quantity in F units. Okay. Okay. So let's try to read. This is the head table. Okay, and we can just kind of yoinkies this shit and just kind of figure out. Okay, let's look again. So we have version, font revision, checksum, magic, flags, units per M. Okay. Then created, modified. Yep. Words, 4 of them, Mac style, then a bunch of like bit stuff we don't care about. Lowest rec font direct, then 2 more. Yeah, looks like this. Okay. So I guess what? We go delete word, end of word, paste, delete, comma. And then we'll have to figure out these types in a second. Okay, so unit 16s are easy. U16, U16, I16, I16, I16. F word, I think that they said it was a signed 16-bit integer. So we'll do this. Long date time is the long internal format of a date in seconds since midnight, January 1st, 1904, is represented as a signed 64-bit integer. Okay, units per EM, U16, U16, U32, U32, and the fixed is a 16.16 signed fixed point number. Does 16.16 mean 32 total? Probably, right? And each side of this thing is, I wonder if it makes sense to do like fixed is equal to a packed struct backed by U32. And then it's uh like the fractional part and the integer part. Like this. Right? It's like gonna be something like this. I think that makes sense. Sure. We can kind of figure this shit out a little bit more in detail later, but for now, let's just kind of yoinkies this head table. So if we find the head table, can we just like print that shit? So we literally like look at the head start and head end. And then can we just be like font data from head start to head end? And this is going to be like a std mem bytes to value head table of this stuff, and then with fixed Indianness. Yeah. Any, I don't know. Like this. Can you have a negative fractional part? Yeah, I guess maybe not, huh? It does seem kind of like the fractional part should be U16. I guess we can always come back to this. Like, we don't really know. So I think that for now, we're gonna say that when we try to fix, I'm sure that this is gonna like crash on something. I'm surprised that this isn't a problem. I kind of expected that the fixed byte endiness would be a problem for these like packed structs, but I guess it kind of figured that shit out, which is maybe concerning. This is concerning, right? This seems wrong. This seems wrong. Like a lot of this stuff seems wrong. So that's quite concerning, to be honest. The head table. So it should be version 1.0, font revision. Can we look for like magic number? Let's start there. Magic number 0. Certainly that's wrong. Certainly that's wrong. So it could be that we were wrong about like what fixed means. Could be. It could be like 8 and 8, but there's no way. That seems really unlikely. Could be that we did this wrong. Head start, head end. Font data from head start, head end. Like, we kind of thought that it should be this before when we started parsing the CMap. Can we print the magic as hex? Head magic. Let's start here, right? Boom, boom, boom. No field name magic. What is it called? Magic something? Magic number? Did we not fix the casing here? We might not have. Magic is this. Yeah, so this is just not at all the same. Not at all the same. FP 48.16 uses that format in design. Only the 16.16 is used for numbers, but the top 32 bits are used as multiplication buffer. Uses that format and is signed. Oh, for this, for the fractional part. Sure. I guess we will see. We will see. Okay, so if I do this kind of the way we were doing it for the CMAP side, seems wrong, man. Like, can we look at the like table? What's like special tables? No, this isn't what I want. I kind of want this top level thing again. So I want to read what the offset value is supposed to be. We might not have understood it. What is entry selector here? Num tables, search range, enter selector, range shift. Table directory follows the offset tab table. Entries in the table directory must be sorted in ascending order by tag. Each table in the font file must have its own table directory entry. Table 5 documents the structure of the table directory. Yeah, so we have offset from the beginning of the font, which is what we did for CMAP, so that makes sense. And the length of this table in bytes. Yeah, so it seems like this should be fine. We look at the table, we start at the font data from head start to head end. And then the magic number being 0 is a big indicator that we've, oh. Oopies. Head magic, let's look at that again. We forgot to write packed. So were we in head somewhere? Head. Here we go. Nope. Use the table checksum as a sanity check, but then I have to learn how to calculate the checksum. We do have the right magic number here now, right? Boom, boom. These are the same number. Look at that. Look at us go. Okay, so now we have this thing, which should be able to tell us, we were looking at this because we wanted to see how many glyphs there were. Which is just not in here, right? So why did we think that? Because when we were looking at glyph, it said something about like the head table. Number of glyphs in the font is restricted only by the value stated in the head table. So if there's a no value for number of glyphs in the head table, what the fuck am I talking about? Right? None of these say how many glyphs there are, unless I'm fucking stupid. Range from, oh, units per EM, created, modified, this, that, max style, lowest rec. Yeah, none of these things are the length. Many of the fields in head table are closely related to variables in other tables. True type fonts that have no outline data but have bitmaps only should not have a head table. They should use byte by byte B head table instead. Dude, am I fucking stupid? The order in which glyphs are placed in a font is arbitrary. Note that we must have at least 2 glyphs. Okay. Glyph table, table 14 documents the glyph definitions. A 0 positive number of contours, single is a simple glyph, blah, blah, blah. Here are some interesting information about a glyph, simple glyphs, but like, how do I know how many there are? I don't understand. See glyph mappings for details. Okay, we have the first index is missing character. The second one is no glyph. All characters in the appropriate character sets must be present. The following character codes must be mapped to the first glyph. But like, how many are there? This feels pretty damning. The number of glyphs in the font is restricted only by the value stated in the head table, right? That feels so damning. But then okay, maybe this mixed directional glyphs. None of the nothing in here says number. Maybe we read a little bit more. Okay, the head table contains global information about font. It records such facts such as the font version number, the creation modification dates, revision number, basic typographic data that applies to the font as a whole. This includes a specification of the font bounding box, the direction in which the font glyphs. Says it's restricted by something ahead. Not that the number's in there, sure, but like, if it's only restricted by that, should it, like, don't we need to know? I guess we can kind of calculate it based off the size of the table. Does that information tell us? Is that information given to us anywhere? So we have maybe that's what we're supposed to do. Is we're supposed to determine if we're using simple or compound glyphs, which maybe that will tell us in here. Glyph data format 0 for current format. Okay. So how? Okay, maybe this is maybe we're on a wild goose chase or something. So there are simple and non-simple glyphs. How do we know if they are simple or not? That is a question that we should be able to answer. Oh, I see. So we look at the number of contours, and for each of these things we say, if it is a simple glyph, then it is positive. If it's less than 0, then it's a compound glyph. And if it's a compound glyph, we hopefully have like a fixed size. Compound glyphs have this stuff. Jeez, come on, man. So we have like this thing that might be any of these. So how the fuck are we supposed to jump to a specific glyph then? Right? Like if the glyph sizes are not fixed, I don't understand how we're supposed to be like, okay, let's jump into this fucking font then. Right? Because in our C map, it's format 4, we are supposed to say, supposedly, the glyph index is something in here, which is just like a number. So how am I supposed to like use this glyph index? You know? Jeez. The glyph index describes the location of the jth component glyph. Values ABC, blah, blah, blah. What is like A, B, and C here? What are we talking about here? This is something about compound glyphs. But like, I just want to know, like, is there no way to quickly jump into these things? So compound glyphs have U16, U16, then these things. Simple glyphs have U16, U16, U8, U8. So this is 2, 4, 5, 6, somewhere between 6, 7, 8, or 10 bytes. Okay? It's either 8 or 10 bytes, right? This thing is 2, 4. Jeez, dude. Okay, one of the transformation options from table 10, which are bits, but like these are like, this is like a bit mask. What is like its size though? Oh, here. We have 3 options. Oh my lord. I like find it really hard to believe that it's impossible for us to just index into this thing. I find it just so hard to believe. Also, where the fuck are the contours? No end of contours. Instruction length, instructions. Oh my god, so there's like arrays in this thing too? This thing is crazy. This thing's crazy. The number of glyphs in the font restricted only by the value in the head table. The order in which glyphs are placed is arbitrary. So I guess, where do the indexes come in here? We have glyph indexes of components. Are like simple glyphs kind of just like implicitly indexed? Maybe. Glyph is made up of components. This has to be the most cursed format I've ever seen. This seems fucked up to me, yeah. So you're gonna end up rasterizing paths and fills? Who knows? Probably. I don't know what the fuck is going on in here. We're gonna do whatever it says. What's in here? Okay, so this is like telling us about what a glyph is. Sure, I don't really care about that right now. I'm more interested in like what the fuck is in the file. Dude, I feel like I'm high. I feel like there's no way that you can't just be like, jump to this index. Because, but I guess, like, yeah, it's fucked. It's fucked. Yeah. Glyph table. Can we like look outside spec? Okay. Let's read the Microsoft thing and maybe they will help us. This is an open type, but I assume this is similar. Maybe it's not. Okay, glyph table is comprised of a list of glyph data blocks, each of which provides a description for a single glyph. Glyphs are referenced by identifiers, which are sequential integers beginning at 0. The total number of glyphs is ooh, okay. Do we have a max p table over here? Oh, baby, let's look over here. Max p table establishes the memory requirements of a font. It begins with the table version number. The next entry is the number of glyphs in the font. Let's fucking go, baby. That's what I want. That's what we're fucking looking for. Okay. Let's look for maxp. Maxp. Here is our maxp table. What? Maxp table. Boom. Okay. Delete word. End of word. Paste. Delete. Comma. Q. 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 Everything that says U16. U16. Okay. Then here we just go everything that says head here. Everything that says head. Maxp. Boom. And then head table here is maxp table. And can we look at the maxp data? Let's take a little look-skis. What's it say? This is driving me nuts. Get branch whip origin whip says fatal, not a valid object name, upstream whip. But get fetch origin whip does not create origin whip, only fetch head. What the fuck am I supposed to do? I thought I knew get. So I think get fetch will like pull the thing in, and then you can check out origin / whip, and that will like bring you there, and then you have to check out a new branch after. I thought. So I think it's like get. I think like get fetch is just like bring shit locally. So if you're trying to do like, I've never done the syntax get branch AB. I've never seen that. I don't know what that does. But what I usually do is I do like git fetch all or something. Git checkout origin whip. Git branch dash b whip or something. I think that's what I do. I think, but I don't really know. Gets hard, man. All right, what am I doing? We're trying to look at this thing. Okay, so our max table claims we have 1573 glyphs. So if that's true, then these glyph indexes are possible. They're not like guaranteed to be wrong, which is kind of interesting. I kind of thought that A1425 seemed crazy, but maybe. I mean, it's not impossible, right? So I guess, I mean, it's kind of hard to say, but we know here from the max table the version is supposed to be 1.0, so it's likely that we have the integer and fractional components of this thing flipped. So let's just kind of do this really quick, just to get a little bit closer to a correct fixed thing here. Good eye, Iliante, you have the same thought? Okay, so let's keep reading this Microsoft version of the glyph definition. The location table provides an array of offsets. Let's go, baby. Holy shit. This is so much easier to read. Fuck you, Apple page. This is great. All my questions are answered immediately. Okay. Laka. Choo choo. Shut the fuck up. Okay, so this tells us where in the table this thing is. What does like the Microsoft version say about the laka choo choo? L. Get fetch dash dash all does not in fact fetch all. I'm going insane. Feel free to ignore, but someone in the chat knows. Help. Yeah, that's kind of fucked up. I guess maybe your origin is not right. Yeah, I don't know, man. My guess would be that yeah, I don't know. It's crazy that you're like just trying to check out a branch and struggling, so I don't really have a good answer for you. Okay, Laka is literally just like we're either in short format or long format. Okay. Offsets may be in ascending order. Length of each glyph description is determined by the difference between the two consecutive things. Sure. By definition, glyph index 0 points to the missing character. Sure. There are two formats of this table. So we determine it by looking at the head table. Okay. So we look at the head table. We look at index to lock format, which we have somewhere probably. Yep. And in head, in index to lock is 0 is short and 1 is long. So head is going to be head. And can we just like fucking run that shit? Here we're going to say that the index lock format is 1. So here I guess we'll just assert, because I don't want to figure out the tracking right now. This should be 1. And then here we can assume that in the Laka table that we're using the long offsets. For now, okay. So this is Laka start and Laka end. And we are gonna look at the font data here, right? And we'll say this thing needs to be like cast to a bunch of U32s, right? And we'll just say here, assuming offset format 1. Okay. Offset or like the long offset format. See assertion in head. Okay. Oopsies. Okay. So offsets is going to be this. And then why is it +1? Because +1 determines the end of the thing, I guess. Okay. Sure. So is there anything else in here? Like, is there something, do we need to worry about like missing? A missing character is commonly represented by a blank box or a space. If the font does not, okay, I see. Sure. So can we just look at like, I don't know. What is the order of these things? They're kind of like sorted by name. So really we're supposed to do some sort of like first pass parsing and then do the rest later, but we haven't done that right now. So maybe we'll just kind of like remember this thing. Can we be like offsets at here? A glyph start is here. I guess we'll do a glyph goes from here to here. 1, 4, 2, 6. Ooh, that doesn't look right to me, right? That seems insane. Right? That is a big fucking character. Like, insane. But I guess... we didn't mem swap. We did not mem swap. Fix slice endiness. Oh, scared the shit out of me. And then we have to like align cast this, which I think will be fine because I think there were requirements on the shit. Okay, that's way more reasonable. Well, no, that's also not reasonable because he thinks that the glyph size is 0, which doesn't seem reasonable. What about like 12 to 13? What are we seeing here? So those are really like a reasonable side. I'm concerned about this a little bit. This makes me think that the glyph index that we calculated for A is wrong. That's kind of the assumption here, that this stuff is wrong. Because otherwise we would I don't think that the glyph should be 0 sized, right? For like a common letter like A. There's no way. There's no way. Which means that it's the most likely cause for that is that we just fucked up the glyph index calculation. Very, very likely. So, let's try this again. Let's look a little closer. So in the glyph, it was in the CMAP section. We should be seeing in format 4 the glyph index array. Let's look at this calculation again. So we have the ID range offset plus 2 times ID range offset at I plus 2 times C minus self start code. That makes sense so far? In bytes, so dividing this by 2 also seems reasonable. This ref maybe is wrong. Maybe? Because this comes from the ID range offset, the address of this thing that we wrote. Read, right? So we have ID range offset base. Yeah, all of this feels kind of okay. This comes from the data at the byte offset that we're at in the initial data, which also seems reasonable. ID range offset reader, yeah, I don't know. Alternatively, one might use an expression such as this shit show, ID range offset I over 2. Plus C minus start code I. Right, okay, so this is in U16. This is in U8. Yeah, I mean, this also lines up with my understanding. Um... Given by the following equation. Yeah, I mean, all of this seems reasonable. By some metric of reasonable. It's possible that we fucked up this stuff as well. So I wonder if it's... Keeping these things as U16 seems pretty fucking reasonable as well. Base? I think we don't need to do a cast here. Oh, maybe we do? Because we're trying to say that the base of this thing is we're literally taking the... Yeah. Something's wrong, and I don't know what it is. 2 times C minus start code. Offset into this thing. Is the endianness fix wrong? I doubt it, but we could check. So, oh yeah, there's no fucking way. Because this is way above the max number of glyphs. So, this seems a little more reasonable for sure. I guess we could double check also. Can we like print the start and end codes here? Std debug. Yeah, std debug print start and end of this thing. So this is going to be subtable start code I and subtable end code I. So where are we? We're supposed to be in the CMAP. Start and end. So we have 58 to 126. Can we print this in hex? Yes, this is supposed to be 3A to 7E. So 3A to 7E. So literally like a big chunk of these things. So calculating for all of these things is reasonable for sure. Like all of these letters seems pretty reasonable. I'm concerned a little bit about seg count here. So can we look again just a little bit closer about the ID range offset? So this is supposed to have seg count elements. And what is delta? Each segment is described by a start code and end code, an ID delta, and an ID range offset. Okay. So maybe we fucked up these there. To use these arrays, it is necessary to search for the first end code that is greater than or equal to the character code to be mapped. If the corresponding start code is less than or equal to the character code, then whoa. It is necessary to search for the first end code that is oh, we just did this wrong. That is greater than or equal to the character code to be mapped. Okay. Search for the first end code. Okay, so for while if subtable end code I is greater than or equal to A. First end code is at index I. Or maybe we'll do this way. Yeah, okay. Zig run. Did I fuck up something where I accidentally deleted something? I did. Oopsies. D offset range base. Hello? What the fuck did I do? D range offset base. This is supposed to be ID. Okay, let's try that again. Zig run. So first encode 5. Oopsies. I wanted to do the kind of like the range here, I think. Okay. So these are the same. Okay. Which means that then he says if each segment is from start code to end code, if the start code is less than or equal to the character code, then use the corresponding ID delta. Okay, so it is less than. Right? We've confirmed that. Then we use the ID delta and ID range offsets to map the character code to the glyph index. So where the fuck does ID delta come in? If the ID range offset for the value is not 0, then the mapping of the character code relies on the glyph index array. The character code offset from start code is added to the ID range offset value, blah, blah, blah. Once the glyph indexing operation is complete, the glyph ID at the indicated address is checked if it's not 0. The value added is added to ID delta to get the actual glyph ID to use. If it's not 0, why? Okay. Fine. So if this is not equal to 0, return ref offs over 2 plus self ID delta at I. Otherwise, return 0 probably. Okay. So this is now 37125 because we need to do a fucking we need to fix this fucking byte order probably. Unless we already did that. We did already do wait. Do we fix the fucking endianness of these ever? Oh yeah, we do in read array. We do in read array. Okay. So now the glyph index for A is 37125. Not this shit. But the maximum glyph index is way smaller than that, right? Num glyphs is 1573. So our ID delta just has to be wrong, right? Like, it has to be. ID delta, is it supposed to be a bunch of U16s? It is. So can we like look at ID delta I? Std debug print. Delta is self, ID is a number. At self ID delta I, right? Simple. Oh, delta 0. Wait, that seems reasonable. So why did these numbers change? Am I fucking stupid? I might be. Is there some sort of stack alignment shit going on? Like if I'm accidentally referencing like stack memory somewhere, then it could be causing some of this. Weird. Aren't those offsets? I don't think they have to be less than the number of glyphs. They're offsets into the glyph index array. And we're supposed to end up getting the index of a glyph from this thing, which we then use in the Locka table to find the offset. Oh my god! Wait, hold on. Oh no, hold on. We're not doing any IDL delta because our ID delta is 0. Okay. ID delta is supposed to be an I16, which is also kind of interesting. Hello? How can ID delta be negative if it's a fucking U16 array? Oh, I guess because sure, it's because they just do mod 65536 and it kind of turns to that. Wait, how can ID range offset be 0? Ten is mapped to 10 minus 9 or 1. Whoa, 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 whoa. How are we getting... These are going straight to indexes? Segment 1, segment 2, segment 3. This isn't using the fucking pointer value at all. Right? Am I fucking stupid? Am I high? Ten is mapped to 10 minus 9 or 1. So start code is 10. Oh, wait, these ID range offsets, are they used? Start code? 20 is mapped to 20 minus 9 or 11. So where's the 20 coming from? Oh, 20 is here. 30 is mapped to 30 minus 18 or 12. Okay. Sure. But then how is this related to the glyph index? This performs the mappings. The following table gives an example of how parameters used to map characters 10, 20 of a continuous range of to a contiguous range of glyph indices. Oh, if the ID range offset is 0, ID delta is added directly to the code to get the glyph index. Fuck. Okay, so what is my ID range offset? Std debug print ID range offset is this. Jesus Christ, man. Self ID range offset. Please tell me it's 0. That sounds way fucking easier. Oh, fuck. ID range offset at I. No. Okay, so this is positive. So the ID range offset value, the mapping of the character codes relies on glyph index array. The character code offset from the start code is added to the ID range offset value. Okay, chill. This sum is using an offset from the current location with ID range offset itself to index out the correct glyph ID array value. This indexing method works because glyph ID array immediately follows the ID range offset font in the font file. The address of the glyph index is given by the following equation. Seems reasonable, man. Then we get ID delta of 0, so it's just like nothing changes. So, I mean, the candidates here are definitely that the ID range offset base is wrong. But I don't really see how. We literally just take like the data plus the index. I mean, we could maybe store this. It might make more sense to store this directly as the index in the parser. I kind of like that. So now this is just like a literal like byte offset from the beginning of the file. Beginning of font file for ID range offset. Did you remember the byte swap? I'm pretty sure, but I might not have. So then we can do this like pointer arithmetic again, and the pointer arithmetic will now turn into a. We need to look at like the data, the font data here. Okay, so we're gonna be like, give me ID range offset base plus this extra offset plus 2 times the distance between these and these because we need it's 2 bytes per thing. And so now we look at like font data from offs to offs plus 2, right? Because this glyph index address is U16. So std mem bytes to value U16 of this thing, and we need to fix its endiness. Okay? This should be what we return. Maybe. Maybe. We can try this and see if that works any better. That doesn't look promising because A and C now have the same fucking values. That's not good. Okay, let's look at this again. So, oh, because this isn't from the beginning of the file. This is from the beginning of the CMAP. From the beginning of CMAP. Which means that we should be doing from CMAP data here. So do we have the CMAP bytes? We have parser CMAP bytes here. Let's try that. Dude, everything's so hard. That's like less stupid. We could try looking at these. I mean, I'm like, it's a different value, but it's also like not like guaranteed insane, which maybe is good. So can we look at 630 here? So 631. A glyph. So that's like not 0 sized anymore, which is good. And we could be totally wrong here, I think, right? Who fucking knows? But there's like a chance now that we could start reading the glyph data for the letter A and start rendering it. But it's 4:30. We haven't started doing any font rendering yet. I'm sure that doing the font rendering will fucking suck, right? And so I think probably the play here is to come back tomorrow. We are kind of at the point now where it makes sense to start like extracting data about the glyph. And I think that once we kind of do that, then we can kind of check tomorrow if our lookup here is correct. So yeah, I think we kind of call it there for today. My head hurts. There's a lot of stuff. This file format is, I'm sure there's reasons for it to be the way it is, but I don't like it. You know? But that's okay. Okay. So yeah, we'll call it there. Thanks for watching, guys. If you like what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4:30 now, so anywhere between 4 hours ago and now if you're watching live. If you're new here, there's a YouTube link in the Twitch description where we have all of our previous VODs archived. So if you want to check out what we've been working on like this image editor that I'm pretty pleased with, but we have a lot of other cool stuff in here. There's stuff like a virtual GPU implementation, a GDB implementation, like regex engine that we've shoehorned into the kernel, like a Google Maps replacement. There's all sorts of fun stuff back there if you want to check it out. If you're watching on YouTube, there's a Twitch link in the YouTube description. You can swing by and say hi if you're online at the right time. You might be watching the YouTube VOD and being like, it's a little short. That's because we split it up into a 12:30 to 2 segment and a 2 to 4 segment. 2 to 4 segment is what you were seeing on YouTube. The 12:32 segment is called Happy Hour, and it's where we kind of do like cleanup, work on small tasks that don't deserve their own videos, stuff like that. So if you want extra stuff, that 12:32 segment, you have to catch it live or check out Patreon and YouTube members. I think that's all the plugin. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.